All right. All right, problem number 1. The expected value of 2 television sets are predicted as follows. The function below models the expected value in dollars of television A after X years. So this one right here corresponds to television A. And then the expected value in dollars of television B is initially $360 and decreases by $90 each year. So we have f of x for television A, and then we have g of x for television B. So we're basically comparing these two. So television A, we know is f of x equals 100 times negative x plus 4. That's all we know so far. And then for television B, we just have some words. So there's a few things that we need to do because we need to be able to compare these, right? We need to know the y-intercept, we need to know the x-intercept, and then that way we can compare. So let's start with television A because there's already an equation. But what's wrong with this equation and what can I do to it to make it more useful?
Distribute.
Yeah, we're going to distribute because right now this is not written in slope-intercept form. But if we distribute, it'll turn into slope-intercept form. So distributing, I get, this is 100 times negative x, so it's going to be negative 100x. And then 100 times 4 is 400. So now I have y equals mx plus b. This is a lot more useful to me. I know a few things. What do I know about this television? Or about the function? What do I know?
You already know the x and the y.
The x and so you were half right. We know the y-intercept, and then Bianca said the other thing. We know the slope, yeah. So I know my slope is what?
90?
For television A.
Oh.
Negative 100x.
Yeah, negative 100.
I thought we were focusing on TVB, my bad.
Oh, no worries, you're good. So I know the slope is negative 100. I know the y-intercept is 400. But I don't know the x-intercept, right? So that's the other thing I need to find. So how, if you remember, tell me, how do I figure out the x-intercept from an equation?
Input 0.
Yeah, where do I put that 0?
In the
Where the x.
So like this? Oops.
No.
Like this?
No.
No, the other way, right? Because this would give me the y-intercept. But I'm not looking for the y-intercept, I'm looking for the x-intercept. So my 0 goes on the end. I'm going to set it equal to 0. That's how it works. Okay, setting it equal to 0. Now I'm going to solve for x. I'm going to start by doing what?
Subtracting 400.
Good. Subtract 400 from both sides. That leaves me with negative 400 equals negative 100x. And to get x alone, I
divide by 100 negative.
Good. Divide by negative 100. What's negative 400 divided by negative 100?
Negative 4.
Positive 4. Yeah, positive 4.
Oh, I'm sorry.
No worries. Negative divided by negative gives me my positive. So now I have everything. Now I have my slope, my y-intercept, and my x-intercept. So I'm all set for TVA. Now let's move on to TVB. TVB doesn't have an equation, but it does have a word problem. And I can write my equation from the words. So based on the words, what is the slope and what is the y-intercept?
The slope is negative 90 and the y is 360.
Perfect. Negative 90x plus 360. How did you get negative? How did you know it was going to be negative?
Because it said decrease.
Decreasing. That's our key word. All right, so there's my y equals mx plus b. And just like TVA, now I have some information. I have my slope. I have my y-intercept. And I can figure out the x-intercept using the same strategy. So I'm going to set it equal to 0. I'm going to subtract, sorry, this should be 360. I'm going to subtract 360 from both sides. So I have negative 360 equals negative 90x. I divide by negative 90, so I'm literally following the same steps as before. And here, what do I get for x?
4.
Also 4. So in other words, they have the same x-intercept, which means that I can eliminate b and d because they have the same one. So neither of them is larger or greater or lesser. They're the same. But now let's look at the y-intercepts. Which one is it going to be? It's g of x greater y-intercept or lesser y-intercept?
Lesser.
Lesser. So g of x has a lesser y-intercept. Done. Questions on number 1. This one was one of those that we practiced a lot, but they threw in a slightly different thing, which was that the first equation was a little bit different. So being able to distribute and realizing that you had to distribute, that was kind of like the first step that you had to do. And then from there, it was very similar to the ones we've done. I even gave you guys a quiz question once that was almost exactly the same. So do I have any final questions on this problem? Awesome, awesome. Number 2. Another comparing functions, okay? So they had a few of these where you had to compare. Now in this case, the graph of f of x is shown below. So this is f of x. And then it says, which of these statements correctly compares the graph of the function f of x to the function g of x equals x over 2 plus 5. So we have f of x is a graph and g of x is an equation. But again, they made it a little more challenging because something is a little weird about this equation. What's weird about it?
The fraction.
That fraction's a little odd. Did anybody figure out how to rewrite this so that the fraction looks a little bit more like what we're used to?
I
Well-
put 1/2 x.
Yeah. So x over 2, this is saying x divided by 2, but remember that x technically has an invisible 1 in front of it. So you could rewrite this fraction so that it's 1/2 x plus 5. So see what they did? They kind of like put that x within the fraction instead of leaving it next to the fraction. But it was the same thing. So that was I think the challenging part of this problem, because once you have that, once you do that, everything makes a lot more sense. What is the slope of g of x?
1/2.
1/2. And all of these answer choices are asking about the rate of change. So we don't really need to bother with everything else. All we really care about is the rate of change. So I already know the rate of change for g of x. And then for f of x, what should I do?
Rise over run.
Rise over run, yeah. I could pick 2 points. Let's do these 2. Pick 2 perfect points. Figure out your rise, figure out your run. And everything is going by ones, so this is pretty easy. What is my run? How far to the right?
4.
4,
4. And then down?
2.
2. And since I'm going down, that's going to be negative. So rise over run for f of x would be negative 2.
Negative 1/2. 1/2.
Yeah. Negative 2 over 4, which simplifies to negative 1/2. So now I have everything I need. And let's see. Okay. A, the rate of change of f of x and g of x is 1/2. Is that true or false?
False.
False. One is positive, one is negative. They're not the same. B, the rate of change of f of x and g of x is 5. Definitely false.
False.
What is 5? Is it the rate of change or something else?
That's the y.
That's the y-intercept, yeah. C, the rate of change of f of x is negative 1/2 and g of x is positive 1/2.
True.
Yeah, that's true. So there we go. So see, kind of on this test, what they love to do is they make this wasn't that hard, but they made it look hard to begin with. So they try to trick you into thinking that it's going to be hard. So then you freak out, you start stressing, you think you don't know what you're doing, and then that's where you go wrong. But at the end of the day, this is very similar to what we've done a bunch of times during class. So, just always on these tests, try to be smarter than the test. Try to remember that it's trying to trick you and you can't let it win. You have to be better than the test. You can't let it get to you like that. Any questions on number 2? All right. Number 3. Number 3, the solutions to the equation f of x equals g of x are -2 and +1. If f and g are graphed on the same coordinate plane, which statement is true? So my group 3 that I spent some time with today, we did this one together. So who can remind me from that group, what is this called when you have f of x equals g of x? And what does it mean?
Is it the solutions?
We're looking for the solutions. So we're going to figure out something to do with the solutions, but there's a different word and it's on the screen somewhere. What is it called? When it's asking about f of x equals g of x, it's asking for there's Bianca said it, equivalence point. Anytime you see that, alarm bells should go off in your head that tell you, okay, I'm looking for the equivalence point. But then what does the equivalence point actually mean on a graph?
Where they meet up at
Yeah, where they, and there's a key word.
intersect.
Yeah, the intersection. Well, okay, it's asking me about it, but there's no graph in front of me. So this isn't really asking you for what is the intersection point. It's saying, okay, what is actually happening at -2 and +1? And so as a quick review, if it was graphed, let's pretend that there was a graph. We've seen these before. You'll see a graph and there will be 2 functions on it, and sometimes one is really weird looking, but that's okay. So there will be one graph over here and then the other one will be all crazy like this. And you're just looking for the places where they meet. That's all we're looking for. So I see that they meet up right here and they meet up right there. And once you have those points, there's one very specific thing that you have to know. What value will your answer be?
On the x.
Yeah, the x value, exactly. So whatever this number is, like let's say that's 2, and let's say this is -3, that's your answer. Wherever they are on the x-axis is your answer, which means that for this one, this would have been answer choice A. Which answer choice in this problem is trying to trick you?
I believe D.
Yeah, D is trying to trick you because D has that word x-intercepts. But we know that x-intercepts are something different. X-intercepts are where you touch the x-axis. Yeah, so like these points right here are x-intercepts. That's not what it's asking about. It's asking about the x value of the intersection. 2 different things. Do I have questions on how to differentiate between those 2 things? Because at the end of the day, this problem is pretty easy. Like there was no math involved. We didn't have to do any math. We didn't have to do any algebra. We didn't have to graph anything. It's just a memory problem, just a memory problem. All right, number 4. Oh, here's an equivalence point. Okay, perfect. The graph below shows f of x and g of x. Which of the following x values are solutions to f of x equals g of x? So we know we're looking for the equivalence point. We're looking for the places where they meet up. But more specifically, we're looking for the x values. So if you have an answer, go ahead and put it in the chat. Good. Good. I see all the correct answers. Yeah, so we've got one equivalence point over here, and one equivalence point down here. And we don't care about the y value. We only care about the x value for both of those. And obviously we have to estimate it a little bit, but if you estimate correctly, you should get negative 3.3 because this is between 2 and 4. So negative 3.3 makes sense. And then positive 5.2 because you're between 4 and 6. So you had to estimate, you had to realize we're looking for the x values, all of those things in one. And also, for select all that apply, what do we always have to keep in mind? How many answers at least should you have?
At least
3
3.
or 2.
At least 2. In this
2 or
case,
more.
it was, yeah, 2 or more, because I saw a few people only had one answer selected. And that's like an obvious wrong answer because you at least need 2. So if you had to guess, at least make sure that you had 2 or more answers picked. Because if you only had one answer picked, that's definitely going to be wrong. And sometimes it also tells you how many to choose. I think there was a problem that was like select 2 that apply or select 3 that apply. So sometimes you have to read carefully to know how many you're supposed to choose. Questions on number 4. All right. Number 5, this one was a little bit tricky. I had a lot of questions about this one. Even like while you guys were taking your test, I had a few people asking. So I'm glad we'll go over it. So a point, negative 3 comma 5 over comma b is on the graph of the equation 2x plus 3y equals 6. So it's on the graph of this equation. And also on the graph of that equation. Let's call this one A. Let's call this one B. What is the value of B? Okay, couple things. There's a lot of kind of steps to this, but basically we know that this point is on the graph, but there is no graph in front of us, right? So what we need to do instead is figure this one out algebraically. This is where we do have to do some math. Now, I have a coordinate point. Coordinate point is x, comma, y. Input and output. So I know the input, but I don't know the output. So when I have these equations here, what can I do to figure out that output? If I know the input, what can I do?
Plug in the output.
Plug in, not the output, you can plug in what you know to figure out what you don't know. So I know that the input is negative 3 comma 5. That's the input, negative 3 comma 5. And I can use that to figure out my output. Now, here's where it gets kind of nice, and I'll tell you why this is nice. You have two options. You have equation A and you have equation B. If that point is on the graph for both of them, for equation A and on the graph for equation B, does it matter which of those equations you plug it into?
No.
It doesn't.
No.
Yeah. So you can pick the easiest one, and which of those is easier, A or B?
B.
B is way
B.
easier. We're going to plug this into B. So I have y equals x plus 3. I'm going to just plug in negative 3 over 5. And now I just need to add, but you know, we're adding a fraction and a whole number. So what do I need to do in order to add those two together?
Are you supposed to multiply by the numerator?
Multiply by the numerator. You're close, but not quite. You're on the right track. What do they have to have in common in order to add them together?
Common denominator.
Common denominator, right? And the number 3 is a whole number, but I can rewrite that as 3 over 1. But those don't have common denominators. So what do I need to do to convert them so that they have the same denominator?
Multiply the 3 over 1 by 5.
Yeah, we can multiply 3 over 1 times 5, because now I'm going to keep this one the same. 3 times 5 is 15, so this would be 15 over 5. That's how we convert it. We know that we can multiply it by 3, and now they have common denominators, so now I can add. So now I'm doing -3 plus 15. What do I get?
12 over 5.
12 over 5. And that is my output, so that is my answer, 12 over 5. That's what we had to do for this one. This one was tricky. A lot of people were very confused by it. But see, same thing happened, didn't it? They show you a question that looks really challenging, but at the end of the day, we really didn't have to do that much work, did we? The hardest part was adding those fractions together. So do I have any questions on this one?
Where did you get the 15?
The 15 over 5? So what Lauren did was we knew we needed to have the same denominator, so I needed to turn 3 over 1 into something over 5 so that it would match. Well, how do you go from 1 to 5? You got to multiply it by 5. So all we did was the same thing in the numerator. Multiplied it by 5 so that it matches. So this is the same as 15 over 5. Okay, that's how we just converting fractions to make them have the same denominator. Any other questions? All right, moving right along, 4 more problems. Number 4, it's 5, 6. Ooh, what are we on? 6. All right, solutions. So select the solutions to the graph from the following points. Select 3, here it is, select 3 that apply. So we know how many we need to choose. Now we have to take a look. So I need to know which of these are solutions. When we've actually done this problem together, we did it in the past. It's come up in the past. It was from a different test and they reused it. So that's always nice when that happens, isn't it? What do I do? Somebody tell me.
You can already find -6 and 1 and 3, 2 because those numbers are already on the graph.
Exactly. So 3, 2 is right here, and -6, 1 is right there. So I know that if it needs to be a solution, it needs to be on the line, which is 3, 2 is in, and -6, 1 is out. So right off the bat, I can do that. But the rest of them, what's wrong?
They're not on the graph.
They're not on the graph. They're not in the box. They're somewhere out of the box. So who remembers the strategy for when that happens?
Do you find the slope and the y, then plug them in?
We need to find the slope. We need to know the y-intercept, and then we can write our equation and plug in those numbers. So start with, if anyone has the answers, what is the slope? What is the y-intercept?
The y-intercept is 1.
Slope is 1/3.
1/3, good. 1 over 3. Rise over run. Pick 2 points, any 2 points, and look at the rise and the run. 1 over 3. So we know the slope, we know the y-intercept. Now I can write my equation. What would my equation be?
Y equals 1/3 x plus 1.
Perfect. All right. Now that I have an equation, I can plug those coordinate points into the equation and see if they work out. So for example, I'm going to plug in -15 and -4. So for the y, that would be my -4. For my x, that would be -15. Okay, and now I'm going to see if I get the same answer on both sides. So this would be -4 equals, what's -15 times 1/3? Good, Alyssa said it in the chat. Yeah, -5. This is where you multiply the numerator and then divide by the denominator. So -15 times 1 is -15, divided by 3 is -5. And -5 plus 1
is -4.
Is -4. So these match. That's what we're looking for. That's good. that means that this is a solution. So now I have 2 answers in. I know I'm looking for one more because I need 3 that apply. So if the next one works out, good. If it doesn't, then I know it's the other one. So I'll plug 12 and 9. Okay, 9 goes in for y. 12 goes in for x. 12 times 1/3, what's that?
4.
4. And I know 4 plus 1
It's
is 5. So that does not work for me. And since this answer is out, I know right off the bat that the last one has to be true because we need 3 answer choices. So the right ones were A, C, and E. Questions on this one? I know for a fact that the next test you guys take will have a similar question on it. So do I have any questions at all at this moment? All right. Couple more left. Number 7. All right. So for number 7, this one was, hold on, oops, muted. Okay. For this one, it was, what I'm going to say about this one is that it's another one that looks really hard, but then it is easier than you think it's going to be because of the way they write things was kind of weird. So Dimitri invested money in 2 different stocks. After 1 year, he received a letter summarized the performance of the stocks graphically. Dimitri observed that the growth of each stock was the same. Which equation shows the translation of the graph of stock B to that of stock A? And then we've got all of these crazy looking function notation-y things. But at the end of the day, okay, VA of T, which one is that one referring to? Stock A or stock B?
Stock A.
Yeah, this is stock A. And VB of T would be stock B. So without looking at the answer choices quite yet, how would I go from stock A to stock B? Where do I move?
You move up 50.
Yeah, so to go from A to B, you would move up 50. And to go the other way,
You move down 50.
down 50. So we know that it's going to be either up 50 or down 50, but let's actually look at these answer choices now. So this answer choice A is basically saying, and let me rewrite this. This is saying that stock A equals stock B minus 50. Is that true or is that false?
True.
Yeah, that's true. That's exactly true because that's what we just looked at. To get to stock A, you got to start at stock B and go down by 50. You got to take away 50. So right off the bat, this is actually true. But let's also look at all the other answer choices to understand what they're saying. Answer choice B is saying the opposite. This one's saying that to get to stock A, you got to go to stock B and add 50. But that would go in the wrong direction. So we know that this one's wrong because that would be if it was talking about something up here, which is not true. Then the last 2 are kind of just there to confuse you, honestly. They don't really say anything that makes sense. The answer choice C is saying that stock A minus stock B equals 50, which simply doesn't really, that doesn't really make any sense. And then the last one is saying that when you add the 2 stocks together, you get 50. So this, again, very, very confusingly written, but not that hard at the end of the day. So you guys are kind of understanding now, these topic tests are a little bit evil. They really try to get to you. Okay, so any questions on number 7? By the way, how did we know that it was going to be by 50s? Where did you look to get 50?
I looked on the y-axis.
Yeah, if you look, this one starts at 150 and this one starts at 200, so we know that there's a difference of 50 from one to the other. All right, hopefully we'll finish in time. Number 8, consider this inequality. Which of the following statements is true, basically, and select 2 that apply. Okay, again, we know how many to choose. Right off the bat, there's one that's a very obvious answer. Which answer can you easily get without doing much work?
A.
A.
Yeah, we know that this is solid because we have greater than or equal to, so that means I can eliminate answer choice B. That's great. Now for the rest of them, we're going to need to do a little bit of work. So let's go ahead and look at C. If this line passes through the origin, so remember the origin is 0, 0. If it passed through the origin, what would need to be the y-intercept? Think about it. If this passes
0.
through 0, 0, what's the y-intercept?
0.
Yeah, 0. But we know that the y-intercept of this is what?
-3.
3. -3.
-3. So we know that my line is actually somewhere down here. So you can basically cross that one out because logically it doesn't make any sense. Now you could have also done something. You could have, if you know the origin is 0, 0, you could also plug in 0 and 0 to see if it makes any sense. And let's see what happens. Wait, 4 times 0 is 0, so 0 minus 3. Okay, so 0 is greater than or equal to -3. That makes sense, but that doesn't tell me if it's on the line. So this one is a little bit more like you just kind of had to think about it logically for that one. For answer choice D, the ordered pair 2, 5 is part of the solution set. So I'm going to do exactly what I just did. If I plug in 2, 5, I want it to make sense. And if it makes sense, then it is part of the solution. So I'm going to plug in a 5 and a 2. 2 times 4 is 8. 8 minus 3 is 5. Is 5 greater than or equal to 5?
Yes.
Yes. Therefore, you can check that off, and then automatically answer choice D would be out. But if you wanted to double check it, you could do a couple of things. You could kind of sketch a graph. Just kind of simple. We know that this is at -3 and that it's a positive slope. So it doesn't have to be perfect. We can just do a little bit of a sketch. And since I have a greater than or equal to sign, am I shading above or below?
Above.
Above. And when you shade above, is that on the left side of the graph or the right side?
Left.
Left, yeah. So you could have kind of sketched it out to check, but that one definitely is wrong. Questions on number 8 very quick. We have 3 minutes left. Sorry to rush. All right, last question. Another inequality. Which of the following are solutions? Where am I looking? I have a dotted graph. So what's the only place that is
In the
solution?
shaded area.
Yeah, shaded area. If it's on the line, it is out of boundary. Can't be part of the solution. So we're just looking at the shaded area, and I'm just going to check each point. So -3, 0, that's out. 7, -5, that looks good to me. 4, 1 also looks good.
In.
-2, -6 barely makes it, but it is there. If you zoom in a little bit, you can see it's definitely in. And then -1, -8. Oh, sorry, this is, yeah, this one's in, and I'm sorry, this is
Yeah,
negative.
that one out. 'Cause
Yeah.
it's on top.
That's +6, my bad. So that was up here. So that one's out, and this one's in. See, even I make those little mistakes. You just make sure that you read it carefully, do it again, check your answers, because you might make that same mistake where you go to the wrong place. You go down instead of up. So always check for those little silly mistakes. But that was number 9, and I think that's it, right? Oh, there was a second number 9, my bad. Number 10. Okay, 2 minutes left. Let's do this really quickly. He has a budget of $300. Can he go above 300? Or does he have to stay below?
Below.
Stay below.
Below 300, and can he equal 300?
Yes.
He can. So I know I need a less than or equal to 300. And which one's the only graph that goes below and has a solid line?
B.
Below and solid.
C.
Oh, C.
C. There's my answer. That was a quick, I could go through this a little more deeply, but I don't really have the time. But if you did the whole equation and you actually figured it out, this would be like 12x.
I was deciding between C and D.
You were? So
Yeah.
this would be 18x plus 12y is less than or equal to 300. And that would be the correct graph. All right. There is a homework assignment due Wednesday at midnight. The homework is reviewing stuff we learned a little while ago. So definitely make sure if you need help with it, watch the videos, just kind of try and recall. I tried to give you guys like slightly easier ones that are from a while ago so that you don't have to work too hard, because I do want you guys to have time to relax for Thanksgiving. But I would definitely get that done either today or tomorrow so that you don't have to do anything on Wednesday. That is it for today, guys. I'm glad we finished in time. I hope that this was helpful, and we'll do kind of a similar thing tomorrow. All right. So have a good day. Have a good rest of your day, and I'll see you then.
Have a nice day, Miss Lopez. See you on. Wait, when do I see you?
Tomorrow.
I mean, tomorrow. My bad.
Bye,
Bye,
Miss
everybody.
Lopez.
Bye.